In this video, we're going to introduce the topic of rational expressions. A rational expression is the ratio of two polynomials. In other words, it's simply an algebraic fraction. So all of these examples below are rational expressions. And the word rational in rational expressions comes from the word ratio. So a rational expression is an algebraic fraction. We should quickly review our rules for working with fractions because they're going to be the same when working with algebraic fractions or rational expressions. Remember that when we multiply fractions, we just multiply across numerators by numerators and denominators by denominators. Also, remember that if there's a common factor in a numerator and a denominator, we can cancel that before we multiply across. Here, 2 goes into both 2 and 4 evenly, so we can cancel that first. 2 goes into 2 once, and 4 goes into 2 twice. So effectively what we're doing is dividing 2 out of both the numerator and the denominator here before we multiply across. Remember that when we're dividing with fractions, we flip the second fraction, the one after the division sign, and multiply. So 1/2 divided by 1/3 would become 1/2 times 3/1, which would be 3/2. Remember also that this kind of notation, 1/2 over 1/3, kind of fractions within fractions, means the same as this. So 1/2 divided by 1/3 would again become 1/2 times 3/1. This question, again, the same as the one above, which again gives us 3/2. Also, remember that when we are adding or subtracting rational expressions, or rather adding or subtracting fractions, we need to find a common denominator. The lowest common denominator here of 3 and 4 is going to be 12. In order to get 3 up to 12, we need to multiply it by 4. If we do that to the denominator, we need to do the same to the numerator. So 1 over 3 becomes 4 over 12 as we multiply both numerator and denominator by 4. Similarly, to get 4 up to 12, we need to multiply the denominator by 3, so we do the same to the numerator, and 1/4 becomes 3/12. So 1/3 plus 1/4 becomes 4/12 plus 3/12 is 7/12. And again, rational expressions are going to follow all these same rules. There's another thing we need to keep in mind with rational expressions, which is that we can't have zeros in our denominator because you can't divide by 0. So that's going to require us placing some restrictions on what values x can take in our rational expressions. We need to disallow or prohibit x from being anything that would make the denominator 0. Let's take a look. In this example here, 5 over x, we need to ask ourselves, what values could x take that would make the denominator 0? And here's relatively simple because the whole denominator is just x. So if x were equal to 0, that would make the denominator 0. We can't have that, so our restriction is x cannot be equal to 0. An equal sign with a diagonal line through it. Let's take a look at the second example. In this case, it's a little bit more complicated. This whole denominator can't be equal to 0. So let's look at what would make it 0. Well, for x plus 3 to be equal to 0, if we solve for x here, we get x is equal to -3. So we want to disallow that, so we say x cannot be equal to -3. That's our restriction here. So we're placing a restriction on what x can be to prevent the denominator from becoming 0. In this case, down here, same thing again. We don't want x squared minus 4 to be equal to 0. So first let's figure out what would make it 0. Well, x squared equals 4 as we solve. That means that x is equal to plus or minus 2. In this case, if x were equal to either positive or -2, that would make the denominator 0. So our restriction in this case is x cannot be equal to plus or minus 2. So rational expressions are algebraic fractions, and because we can't let the denominator be 0, we have to place restrictions on what values the variable can take.